Hello everyone, welcome. This is the first meetup we've hosted here at Vongel Berlin. I just wanted to be a part of the community. I just moved out here about a month ago, so I'm glad we were able to get this set up. My presentation is going to be about collecting all of the things. We want to make sure we collect all of our metrics as much as we can, and that way we can transform our data however we like. Who am I? My name is Felix Rodriguez. I'm a DevOps engineer at Bungle. I've been working in Bungle for over a year now. I've been in the DevOps field for about 2.5, 3 years now. And I really am passionate about the industry. I think DevOps is really cool, especially like working with new tools, working with metric pipelines, and basically researching and developing any new services we can find useful. I'm also a Golang developer. I work on a bunch of small little projects that I hope to share with people and generate traction. Nothing too big yet, but hopefully that'll change today. Um, you can find me on GitHub at Philobot or Slack. I'm on the Kubernetes and Gopher Slack groups or Slack teams. And you can also find me on Twitter. I'm a digital nomad. This is probably the fourth country I've lived in the past 5, 6 years, and I love it a lot. I love being able to travel around. Luckily, Vungle lets me do that. Who is Vungle? They basically are working to try and make mobile ads suck less. We have our own creative team in London. We have about 150 total employees. Our main headquarters is in San Francisco, where I moved from. And we have offices in Tokyo, Beijing, pretty much all over. Basically what we're doing is providing an SDK for game developers or for any application developers to trigger when they'd like an ad to play, and we work on making sure that that ad is engaging and it's directed towards the right customers. There are a lot of tools out there. I know it's a little overwhelming. There's competitors to everything that I'm going to be talking about. For Kubernetes, we have Amazon ECS, we have Rancher, we have Mesosphere, and we have other competitors to InfluxDB like Prometheus. But I'm going to talk about the tools that I think work really well together and help me solve a problem I was trying to solve, and I'm sort of using it as a framework to achieve a goal that I wanted to achieve. So Kubernetes, if you're not familiar with, is kind of like a container scheduler. It allows you to request what containers you need to run and how much CPU resources they need, and the Kubernetes API will go ahead and schedule that across. It'll monitor that to make sure it's always running, and it does provide you with logging, at least directly to the container, and a lot of other nice features out of the box. It allows you to build, test, deploy, and push using like a common set of config files. It has deployments built in, which is great. Uniformly scaling and monitoring your system. Basically, you can scale all of your services the same way, which is awesome. You're just defining config files, like I said, and it requests to Kubernetes what it would like to do, and then the scheduler tries to fulfill it. It's cloud agnostic. We're running it on AWS currently. We're looking into GCE to see if we could maybe take advantage of their hosted solution, make things a little bit easier on us. Kubernetes was a little bit tough to set up at first, but it is amazing at what it does. It also does secret management, which is really cool. We can have secure encrypted files stored in the Kubernetes API, and then all of our services can then access these files without having to worry about people putting the tokens in plain text or passwords in plain text across their services. And then it also supports jobs and daemons. Think of jobs the same way as like Jenkins runs jobs. It's a one-off run, and then it expects a positive, or it expects a positive output of whatever is being run inside the container, which is really cool. And daemons are basically saying this service needs to run across all of my nodes, and these are really good for any kind of system tools you want to have running on your nodes, or monitoring tools actually. So what I'm going to be talking about is I'd like to call KubeMon. It's basically a collection of these configs that allow you to deploy these pods and services to help monitor your Kubernetes cluster. It's currently working, the configs work better locally as a one-off command to start off, but you can go ahead and deploy these on a production cluster as well. You might want to tweak a few things for basically CPU limits and memory limits and those things. Basically, it's a collection of Heapster, InfluxDB, Grafana, and Capacitor. Capacitor is not exactly a part of the Docker deployment or the Kubernetes deployment because it's not Dockerized yet. Capacitor itself is Dockerized, but it doesn't work well in a Dockerized environment with the rest of these tools currently, specifically Heapster and InfluxDB on their latest versions for some reason are not working too well together, but I hope that it'll be resolved quickly. That way we can launch all of this in one command and get alerting, all sorts of fun stuff without too much hassle. If you don't know what each one of these are, I'm going to dive into each of these a little bit. But feel free to check out the project. It's open source. You can get started in the local development environment really quickly. This is a tool that I made. It's called LabelGun, and it basically gives us a one-to-one state of our system from AWS to Kubernetes. Basically, Kubernetes is not aware of what these nodes that are a part of it, how do they relate to AWS. So we're getting all the metadata off of the AWS nodes, and we're putting it into Kubernetes API and letting it know that these nodes are of specific instance type, specific availability zones. That way, all the metrics that come in, we can get this data, and we can later use it for another service I'll show you momentarily. KubeWatcher is another thing that I built, and what it does is it watches the Kubernetes API for any kind of pod changes, and it submits those as metrics, or not metrics, sorry, as events to Datadog. I won't go too much into it right now, but it's just a really cool thing if you're using Datadog and want to extract those events. It's also a good example of how you can use the Kubernetes API to achieve any different goal you want to achieve. So Heapster is provided to you from Kubernetes. It's not currently packaged together. It is in GKE, which is the Google container engine. And what Heapster does is it uses cAdvisor to gather metrics from all of your nodes, from all of your containers, and it provides an API endpoint for you to get this data. And you can also provide Heapster with a sink, which is basically a data store that you want to put these metrics into. And one of those that it supports is InfluxDB. You can also use Google Cloud Monitoring if you're in GCE or GKE. But we are currently running in AWS, like I said, so we're using InfluxDB. On the right, you'll see an example of what stats are being collected. So you have some good ones like CPU limit, node utilization, memory limits, uptime. All of these are really great, and some of these we'll be using to accomplish one of the goals that I'll show you later on. Also, Heapster is required for auto-scaling. May not mean a lot to you right now because if you're not using Kubernetes, but what that means to me is that this tool is going to become more integral part of Kubernetes in the future, so we can expect this project to grow and become even more useful in the future. InfluxDB, if you're not aware, is a time series database. It's pretty awesome. It's grown a lot in the last few years. and basically it's an open source Golang binary that stores data at an awesome compression rate. It's really easy to query. If you're familiar with SQL, you can use it just like you'd use anything else. And it accepts multiple protocols, so you can send it using the Graphite API or whatever tool you're currently collecting and emitting metrics as. It offers a hosted solution as well. Their enterprise version is clustered, and it may be something we consider in the future in case we want a backup location for more important metrics that need to be stored for a longer period of time. It is super efficient, and it works really well with Grafana. Which brings me to Grafana. If you haven't heard of it, it's amazing. The graphs that come out of it are just phenomenal. My graphs look nothing like this, but if you're really talented and if you spend a lot of time, you can do awesome things with it. I find it a lot more intuitive than using stuff like Kibana, but I will show you what I was able to create, and it wasn't too long that it took me, but it was pretty nice. It doesn't look, like I said, as nice as this, but it is very useful. The last piece is capacitor, and this is the piece that I'm most excited about and actually really honored to be able to be up here and talking to you about it, because I've been looking at this for a while and I've been wanting to find a use for this, and I finally think that I found something that would help the business, I think. And what it allows you to do is it streams data in real time from your InfluxDB cluster, and you can either stream it or you can batch it, but I really like the streaming part of it. So as these live events are happening, you can process the data, form any kind of computation you can think of, and either push it out back into InfluxDB, send it to a bunch of different integrations like HipChat, OpsGenie, PagerDuty, whatever you're using to create alerts. You can even do a regular post in case you want to send it to your own custom service. And it's really great because you can, like I said, listen to this data that's coming in live and perform actions on it. My favorite part about it, though, is the custom user-defined functions. Basically, you can write in any language a function that will manipulate the data however you want and store it back in InfluxDB, or just submit it as another metric or another value on an existing metric. Some of the cool things that I think that I'm really looking forward to in the future are anomaly detection and basically Dockerizing of the UDFs. Capacitor, already on the latest version, works pretty well with Docker now that it's using the HTTP protocol. It's really easy to get set up and going, and I'll show you an example of some of the tick scripts. This is an example. This is probably one of the first tick scripts that I wrote. Basically looks at all the data coming in from Heapster under CPU usage as a stream, and it always alerts. That's what that lambda true is. It always creates an alert, and the alert logs to temp alert.log. And this was just so I can make sure that it's listening to CPU usage and that the crit worked and that I could use an integration. Right now I'm using just log, but I wanted to test something maybe like Slack. I just didn't want to blow up a channel right away. So I took this and I was like, wow, this is amazing. I'm going to build my own UDF, and boy, was that a challenge. I will say that there's not that many examples besides the one InfluxDB gives you, but thankfully with their help on being on the Slack channel and just talking with these guys, they were able to help me set up my own UDF. And what this does is it's listening to your CPU usage and your uptime, and it's processing that data, and based on an algorithm I created, it's able to show you how much this particular container is going to cost you at an hourly rate. In the future, it would communicate to the AWS API. It doesn't do that currently. It's a work in progress. and it gives you detailed costs on a per container, per pod basis, as I was saying before. I'll show you how this works in a collect script or tick script. Basically, it's storing uptime as a value, as a variable, and then you have the CPU usage, which is also a variable. So these are two streams stored as a variable that are then joined together, and then it's passing it to the collect function, and then whatever value the collect UDF emits, it's going to go ahead and store that as a InfluxDB out. And you can put this into another database. I decided to put it right back into the same database under its own metric called CPU cost, with the same field being filled as value. Basically, once you launch KubeMon, this is what you would get. You'd get a bunch of graphs that are pre-configured for you. This is all Heapster data being sent to Influx, visualized in Grafana, with drop-downs so that you can determine what namespace, what pod, and what application you want to actually monitor. This is super useful, and this is something that any company would want to keep track of. Let me show you how I got all this set up. So I'm going to run through a quick little demo with you. That way you know that I'm not making things up, and you can actually launch this with one command. Oh, that's... Sorry. All right, here we go. So we'll do a little ls so you can see what's here. You'll see that it's just a bunch of config files. They're all YAMLs that are basically Kubernetes deployments, Kubernetes service files, and services basically expose an application to other applications so that they can communicate to each other. So with one little command, which is just a shell script that you can see the code to, it's really, really simple. But it's going to go ahead and create an InfluxDB container. It's going to create the service so that other things can communicate to it. And then it's going to launch Heapster into the Kubernetes cluster so that Heapster is able to submit those metrics to the InfluxDB cluster that was created. And then, let's see, it looks a little hung. There we go, the ingress was created. The ingress is not necessarily needed for KubeMon. I mean for, oh, this is running in Minikube, sorry. So if you haven't checked it out, Minikube is a really cool project. It's also created by Kubernetes, but it allows you to run Kubernetes locally on your own system. And I think that a lot of people, that was what they were missing. They didn't trust Kubernetes because they couldn't really get it working locally. It was really tough to set up. But now we have almost like a boot to Docker version of Kubernetes that you can spin up locally. And here you go. You can see that Grafana is being created. Heapster is being created. It waits for some of these services, so that's why it's taking a little bit of time. And hopefully, if all that works, we'll get a pop-up that will launch Grafana, and we can log into that service and see those errors are fine, those, like I said, are not needed. And we can log into Grafana and look at the dashboard. That should be already pre-configured. The database should be already added to Grafana, and looks like some things didn't tear down well. So thank you, demo gods. I'm just going to cat out this. Promise to make this script a little bit better for next time, but here we go. I'm going to run that. These two curl commands, basically one creates the data source and the other one creates the dashboard for you. And the dashboard's also in the source code. Admin, secret, boom. We're logged into Grafana now. Make that bigger. And go to pod stats. And there you go. There's a brand new Grafana dashboard. It has everything here. And it's already looking at InfluxDB. It's monitoring. We got our first points coming in. And as it takes a little time here to churn, we'll start getting memory, network, CPU, all of these goodies will start coming in. And show you real quick. Okay, good. You can see that these are all the pods that are running. We can go ahead and take a look at the Heapster output. You can see it created the K8s database in InfluxDB. Check InfluxDB out. Oops, sorry. And we can see that's posting. Look at the 200 responses. And we'll go ahead and stop this. And now we see some points coming in for CPU, memory, and all of that, which is great. You'll notice that the CPU cost isn't here yet. One of the issues I ran into was, like I said, capacitor while Dockerized will work well with Dockerized, but it needs to run on 1.0. InfluxDB also needs to be at 1.0 for this to work. And currently, the Heapster data isn't able to post successfully to Influx on 1.0. So it looks like there might be a breaking change there. There might be an old format that they're sending the code, but once that is fixed, capacitor will be loaded up. You'll automatically see CPU usage, CPU hourly cost, and the way that that works, I'll show you in a second. Looks like I had this running already, so I'm going to stop that. And we'll take a look at the source code. Basically, this is an example of a UDF. You have your info, which lets it know what options you can provide to this. If you look at the collect script, you'll see there's only one option. It's as. So we're going to store whatever comes into here under the field value. Sorry. And if it doesn't have it, we're going to error. We're not doing any snapshots. We don't support batching. And then here's the goodies where it computes the cost. Now, total millicores, that's how many millicores you have available in your entire cluster. This right now is a static variable, but it will be one of those option fields that you can pass in. And hourly rate will also be, that's how much your cluster costs per hour. That will also be a field that you can pass in, and you'll have to calculate on your own until Collect is able to pull this information automatically from the AWS API. We cannot get this data dynamically yet. And then CPU usage and uptime, that is dynamic. That's pulling directly from the Heapster metrics, and then it's basically able to use that algorithm to determine how much that service costs, and it'll reinsert it back into the same point that it received under a different metric name and value. To see how this all works, I'll show it to you on one of our production clusters. And here you go right here. You notice it stopped because I stopped running it. and you can see what the average current at max cost was. Go ahead and launch this again, and I'll take a look at the capacitor conf, because the only thing you need to supply for your custom UDF to work is where the program file lives. Ours is a binary, so we don't need Python or anything to run it. And it lives in the current directory, and basically what timeout you want to give it for it to process the data. Once that's there, your tick script will know that you can use this as an option. Sorry. And then we'll go ahead and run it. So basically, you'll see it running there. And then we should be able to go back to, this is the one we just launched, should be able to go back to the one we're currently running in production, and you'll see some points coming in. That's basically it. There you go. Boom. They're there. And see if I can get my slides back up. Looks like it must have crashed. We'll do one of these. Luckily I had sent it out. Oh, there it is. It was hiding. Present. Sorry about that. And so basically what's next, we are hoping to, like I said, automatically retrieve how much your cluster costs and insert that into the collect UDF function automatically. And then we would love to have email or Slack reports on the top 5 most expensive services that have been run. Love to have collect running as a container. That should be supported in future versions of Capacitor. I'd love to have Capacitor as a pod. That depends on Heapster and Influx playing nice in future versions. And then we could have one deploy command to have full cost and service monitoring with a dashboard, with continuous queries, all of that stuff that downsamples your data. I want to have all of that in an easy to launch config, and maybe some better algorithm to determine cost. I'm open to suggestions. Once we have all of this, we can see, is this working well for us? Is there a better way we can determine how our cost is versus just doing CPU and memory costs separately? And what would be really cool is if it knew that, oh, hey, I'm running in AWS. I can see from my tags that I'm an instance of this type. Let me query the Amazon API to get more details about this. Figure out if I'm an on-demand, reserved, or spot instance, because they're all different prices. Figure out how much this node is costing to run, and then know the exact cost of that container on that specific node that it's on. That way you can aggregate it across your entire cluster. And cost badges, I mean, who doesn't want more badges on their GitHub profile? It would be great to have a nice little badge that says, if you launch this, it will cost you no more than this on Kubernetes. And I think that's a good goal to shoot for, is you want to make services, you want to make applications that are not memory hogs, that are not CPU hogs. And what better way to show that than like a nice shiny little badge? That's basically it. That's my talk, and I hope you enjoyed it. You can find me here, like I said, on Twitter, GitHub, Slack, and shout out to Bungle for letting us host this meetup tonight, and hope you guys all have a great night. Thank you.